to kind of step it up a little bit today. Try to give some more thought-provoking questions here. So car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. So what should we do? I'm going to be drawing a picture. Both are headed for the intersection of the two roads. So they're both heading here, okay? So if car A is traveling west and going to this point, where's car A? Which side of this? So here's car A and it's traveling this way. And where's car B? It's below this. It's traveling north. Okay. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? Okay, so let's go ahead and extend these to make a triangle. This would have to be a right angle because we had this one was north, that's west. Let's call this side A and this side B. What would 50 miles per hour represent? It's a velocity. A velocity is a derivative, right? How do we write those? And since it's the velocity of car A and this is side A, let's call that dA dt. So the speed of car A is 50. Car B is traveling 60 miles per hour. So what would I call that? dB dt equals 60. Okay, the other numbers. Car A is 0.3 miles from the intersection. So what's that? A. Car B is 0.4 miles, so that is B. We want to know how fast the cars are approaching each other. So if I want to call this side, let's call it C. If I want the how fast, what am I looking for?
DC.
Could you find C at that particular instant? How do you do it? So 0.3 squared plus 0.4 squared equals C squared. So C is 0.5. Okay. What kind of formula would we use for this? Equation. It's an easy question. I already used it once to find C. So anytime we're dealing with right triangles, it's very likely that you are going to be setting up the Pythagorean theorem. When we do that, what do we have to do? So what would be the derivative of A squared? 2ABA. Plus, what's the derivative of B squared?
2B
And the derivative of C squared?
2CBC.
So now we plug in everything. So A is 0.3, dA dt is 50, B is 0.4, dB dt is 60. my unit speed? C is the distance, that was in miles. T is the time, that was in hours, so it's miles per hour. So they are approaching one another at a speed of 78 miles per hour. Questions here? So on the next one, I want you guys to read it and see how far you can get on setting it before we try it together. Let's kind of just check what we've got. So we have a girl is flying a kite on a string. So depending on how creative you are, here's our kite. I have lots of artistic ability, so there's my kite. The kite is 120 feet above the ground, so what would that be? How would I draw that? Okay, so that's like saying this side right here, or you could have drawn it over here, it doesn't matter. And the wind is blowing the kite horizontally away from her at a rate of 6 feet per second. So this kite is moving, okay? The wind's blowing it, she's letting the string go, so it's heading out this way. Is the 120 feet constant, or is it changing? It appears to be constant. It doesn't say that the kite is going up higher in the air. So we could go ahead and label this with the number. Now, if as we are letting the string go, the kite was going higher, then we would have to keep it as a variable. But because it's just staying at that height, the only difference is it's getting further away from her, the wind is just blowing it straight out, we can keep that at 120. So we would need some kind of variable for this, let's call that about y. And we know it is going further away from her, so this is also going to change. So I'm going to call that x. So if we look at this, the horizontal speed is 6 feet per second. So my horizontal is my x. Anytime, I told you, anytime your units are a rate, that's a derivative. So dx dt. You notice x is in feet, t is in seconds, so x over t. At what rate must she let the string out? So the string is y. If I'm talking about the rate, we are looking for dy dt. When 130 feet of string has been let out, what is that? Y. Okay, is there anything else I need? We're going to need x at that instant. If you don't find it now, you'll notice when you go to plug in things after your derivative that you're missing something. So we could find our x at the instant when my y is 130. How would I do that? X squared plus 120 squared equals y squared. But we're looking at the instant when my y is 130. So 130 squared minus 120 squared. Square root, and x is 15. So now we need to set up an equation that we can do the derivative of. When we have a triangle, we're kind of doing the same thing every time. Pythagorean theorem. So x squared plus 120 squared equals y squared. What's the derivative of x squared? 2x. dx dt. What's the derivative of 120 squared? 0. It's constant, so we can just drop that. Derivative of y squared?
2.
So if we plug in x is 6, x is not 6, x is 50, dx dt is 6, equals 2 times y is 130, dy dt. This one does not come out perfectly, so we will just leave it as a fraction. So 30 over 13. I'd like to get in the habit of putting units on these. What would be the units on y? Feet. Per, the minutes on t, or the units on t. So 30 over 13 feet per second. Next one is a little different. I want you to again try it on your own first before we talk about it. After we check the picture. So a water tank has the shape of an inverted circular cone. What does that mean? Inverted means upside down. Circular cone. So it's like a party hat flipped upside down, or like a waffle cone for your ice cream. Okay, so it's just an upside down cone. Okay, what I want you to do is take a second now that we know what our shape is. See if you can write down what all of these numbers represent. Base radius of 2 meters. Where's that? It's talking about the starting radius. Now, is this radius always 2 meters? No, because as you go down it gets skinnier, so that radius is going to change. The height of this whole cone is 4 meters. Water is being pumped into the tank at a rate of 2 cubic meters per minute. What is that? Volume. But it's per minute, so it's not just V, it is dV dt. What if I said the water was leaking out at a rate of 2 meters per minute? What would you do? Negative. Find the rate at which the water level is rising when the water is 3 meters deep. So the rate, so a rate is a derivative at which the water level is rising. I'm wanting the derivative of what? What variable measures? I'm talking about how tall that is.
DH.
Yeah, that's my height. We're looking for dH dt. When the water is 3 meters deep, so what does the 3 represent? That's our H. So we want to know how that water level is changing at the instant when it has a height of 3. Okay. So this is a little bit different than what we're used to. Couple things. When we have a cone, volume of a cone is 1/3 pi r squared h. Not a formula I would make you memorize. It's basically volume of a cylinder is pi r squared h, and then a third because a cone is a third of the whole cylinder. Alright, we have three variables here. If I do this derivative, I will end up with a dv dt, a dr dt, and a dh dt in that. Do I have all of those pieces up here? No. I'm talking about dv dt, and I'm trying to find dh dt, but there is no mention of r. So I would prefer to get rid of this r before I do my derivative, because I don't want more variables than I have given you information to deal with. So here's what we're going to do. We know that in this entire cone, the height is 4 and the radius is 2, right? So in general, we could think of this as a proportion. This is to our height, this is our radius. So I could say like 4 over 2 equals h over r. We want to get rid of r, so if we solve for r, so if we just cross multiply, 4r equals 2h, divide, so your radius is h over 2. Does that check out for the original? My radius is the height divided by 2? Yeah. Okay. I'm going to take that and plug it into this equation before I do the derivative. Because even though the radius and the height are changing, we can assume that that radius, or that ratio is always the same. The radius is always going to be half the height. So if we simplify, 1/3 pi, I'm just going to write that as pi divided by 3. If I square this, we get h squared over 4 times h. So we get pi divided by 12, h to the third. Have I lost anybody so far? Okay. Now let's do this derivative. So what's the derivative of v? Okay, over here the 3 comes down. So pi over 12 times 3 is pi over 4 h squared, and that needs dh dt along with that. Now let's plug in what we have. dv dt was 2. What was my h? 3. Bless you. So if I want to solve for dh dt, we could multiply the 4 over. That gives us an 8 divided by the 9 pi. What would the units be? Height was measured in meters per t. Time was measured in minutes. that particular instant, the height was changing at a rate of 8/9 pi. Okay, that one was a little more challenging. Definitely a step up from what we have been doing. What questions do you have for me? We're going to stop here for today. So you are ready for day 2.